So for a discrete domain, that means that when you have a discrete domain, the set of input values that consists of only certain numbers in an interval. So if we look at this, and this is not like a normal graph, but we see this number line, and the number line has points at 1, 2, 3, 4, and 5. The domain of this situation is discrete because there's not a line connecting these points. It's just several separate points here. The example is the integers from 1 to 5. Integers don't have any fractions or decimals, so all the integers from 1 to 5 would be 1, 2, 3, 4, and 5. Which is why the graph just has 1, 2, 3, 4, and 5 listed like that, and there's not a line through it. So the domain of this situation, the domain would be 1, 2, 3, 4, and 5. And that's because the domain would just be a list of those numbers. A continuous domain, though, would be an example like all of the numbers from 1 to 5. Well, if we were writing down all of the numbers from 1 to 5, that's literally everything from 1 to 5, which is why there's a line in between these 2 points showing that you can have fractions, you can have decimals. Like 1.5 would be a solution, 2.2 is a solution, 3.7. So anything from 1 to 5 would be a continuous domain, meaning that you can't just list the domain numbers like we did here. For a continuous domain, you have to use an inequality like we did in the last chapter, showing that anything from 1 to 5 is your solution. So you would use a compound inequality showing that the solutions are from 1 to 5, like that. Okay, moving this on to the next page. The next thing we have here is a function, and we're going to be creating the function and graphing it given a certain domain. We have to identify the independent and dependent variables for the scenarios and determine if they're discrete or continuous. So the first thing is asking us to determine if it's discrete or continuous. Let's look at the example. The function y equals negative 3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you've taken X gulps. So this function is representing how much fluid, so how much juice is remaining in the bottle after you're taking X amount of sips. So first thing is, let's determine if this is discrete or continuous. So well, I guess we can wait for that. Let's first just answer letter A. So identifying the independent and dependent variables. So every time we have a situation, we're going to have two variables. Usually they're going to be X and they're going to be Y. X is the independent variable. The independent variable usually is just like what's happening, and Y is the dependent variable, and that depends on what is happening. So if we're thinking about this situation, what depends on what? Does the amount of juice remaining in the bottle depend on how many sips you're taking, or does how many sips you're taking depend on how much fluid is left in the bottle? The first one or the second one?
How many sips are depends on how much is remaining, like how much you take.
I just want to hear your thinking. What you're saying is like your thinking is right, but I think you're saying it backwards.
Like, what did you say?
I know, it's confusing. So what depends on what? Does the amount of juice left in the bottle depend on how many sips you're taking? Or does how many sips you're taking depend on how much is left?
The amount of sips you're taking depends on how much is left.
So, I mean, I guess I can understand how you could twist it that way, because, like, if you only have a certain amount, you might only be able to have a certain amount of sips that you could take.
Yeah.
But yeah, I know, I understand. But if you have, like, a bottle of juice and you're taking sips of it, the amount that's remaining in there directly depends on how many sips you're taking. So if you take, like the same little sip each time, what's left depends directly on how many sips you're taking. If you take no sips, the whole thing is left. If you take one sip, a little bit is taken out, and then that much is left, and so on. Which means that the dependent variable, which is y, is going to be the amount of juice left be the number of sips or gulps they're calling it. So they're telling us that the domain of this situation is 0, 1, 2, 3, and 4. And they want us to create a table. So you can create a table this way, or you can create a table this way. We're not going to do both, we'll just do one. X and Y will go here and here if it's vertical, and then X and Y would go here and here if it's horizontal. We'll just do one table because the other one will be exactly the same. So they're telling us that the domain of this graph is 0, 1, 2, 3, and 4. Okay, that means your X numbers are 0, 1, 2, 3, and 4. And they want us to find the Y numbers that go along with this. So this means we're going to be creating the table from the function y equals negative 3x plus 12. What we're going to do to get all of these numbers in for y is replace the number in for x and then solve. So we're going to take the little function negative 3x plus 12 and we're going to replace 0 in for x and solve, 1 in for x and solve, 2 in for x and solve, 3 and then 4. So we're going to take negative 3 and replace 0 in for x and solve that little pattern here. Negative 3 times 0 is 0. 0 plus 12 is 12. So the first one is 12, which makes sense. If you take 0 gulps of juice, then you should have the entire amount of juice left. So this bottle must start with 12 ounces. Then the next one, we would do negative 3 times 1 plus 12. And that's going to be how much juice is left after 1 gulp. Well, negative 3 times 1 is negative 3, and negative 3 plus 12 is 9. So there's going to be 9 fluid ounces left. Take a minute and try the next 3. Do 2, 3, and 4. All right, when x is 2, what is y going to be equal to? What's negative 3 times 2 plus 12? Yes, 6. What about 3? When x is 3, what will y be? What's negative 3 times 3 plus 12? Yep. And then what about when x is 4, what will y be? What's negative 3 times 4 plus 12?
0.
Correct. All right, so here are the 4 range numbers that go along with our domain. So we have 12, 9, 6, 3, and 0. Then it wants us to graph. So when we're graphing, each x is paired with a y. So the first ordered pair would be 0, 12, because this is paired with that. And then it would be 1, 9, 2, 6, 3, 3, and 4, 0. So we will come over here to the graph, and we will plot these 4 points, 5 points, sorry, 0, 12. It looks like we have to label this one. We'll go by 2's as well. So 0, 12 would be here, and then 1, 9, 2, 6, 3, 3, and 4, 0. So here's what the graph would look like. The graph does make sense to what I would think would happen. You can see the points are going down, and that makes sense because this scenario is about how much juice is remaining after you're taking an X number of sips. So eventually there's going to be nothing left in the bottle of juice once you finish it. So we can see here that it starts at 12, which means that the bottle must start at 12 fluid ounces, and it goes all the way down to 0 fluid ounces left when you take 4 sips. So the one thing we didn't answer yet, now that we have the graph filled in, is determining if the scenario is discrete or continuous. Discrete means that you should have just a set of points here like this, and there should be no line in between. And continuous means there should be a line in between, and I would draw a line through these points. So we would have to think about that. In order to be continuous, there has to be points in between each little point. For example, like we would have to be able to take 2.5 sips. Could you take 2.5 sips? Does that make sense to put that little green dot there? No, you can only take an integer amount of sips. Like you can't take 2.5 sips. Even if your one sip was more than the other, that's still considered the same sip. So you can't take any fraction or decimal sips. So that doesn't make sense to put another point there in that spot. So I'm just quickly putting this back in there. But this one would be discrete. So this is a discrete graph. It's not continuous. Those points will not have a line through it. They'll just be discrete set of points. The domain would just be 0, 1, 2, 3, 4. The range would be 0, 3, 6, 9, 12. And that would be it for that. Are there any other questions for that one, or is it just on to the next one? Okay, let me erase this, and let's take a look at this next one, which I would like you guys to try on your own. So the function T equals 19m plus 65 represents the temperature T in degrees Fahrenheit of an oven after preheating for m minutes. Identify the independent and dependent variables, and then a recipe calls for an oven temperature of 350. Describe the domain and range of the function. So I'm going to give you guys some time to work with this one. This one's just a little bit weird because they're using different variables. So you have to determine the independent and dependent variables. That means tell me which one T is. Is T independent or dependent? And is M independent or dependent? So look at what's happening here. T represents the temperature in degrees, and M is M minutes. So identify that, and then I want you guys to find the domain and range if the oven needs to be at 350. All right, I'm going to give you a few minutes to try and get started. This one's actually a little bit more difficult. So a few minutes to try and get started, and then after you guys get started with this, we'll do the rest of it together. So try at least letter A, and if you understand letter B, then go ahead and try that. 2 minutes, and then we'll do the rest together. Alright, so first thing is let's identify the independent and dependent variables. Dependent variables rely on the independent ones. So if you're thinking of an oven, if you've ever made yourself your own snack or whatever, you know that you have to turn the oven onto a certain temperature. 350 is a pretty popular temperature, especially for any frozen food, chicken nuggets, mozzarella sticks, whatever. And then you have to wait. You can't just put the stuff in there. You have to wait until it actually preheats, and then you can put your stuff in however long it takes. So this function represents T. This is the temperature of what the oven will be. Is equal 19m. M is how many minutes? Plus 65. So we have to think what relies on what? Does the temperature rely on how many minutes you're preheating it? Or the opposite, does the minutes you're preheating it depend on temperature? And I know it's kind of weird because when you say it in the opposite way, you can kind of like string it that it would make sense. But the temperature of the oven directly relies on how long you're preheating it for. Because if you don't preheat it at all, it's going to just be like a normal room temperature. You preheat it for 5 minutes, it's going to increase. 10 minutes, it's going to increase. So the independent variables and the dependent variables would be M is the number of minutes. This is the independent variable. And the temperature depends on how long you are preheating it. So T is dependent on M. If you're looking at this equation, T equals 19M plus 65, usually we would use Y and we would use X. And when you have X and Y instead, if you're looking at these instead, it's usually Y equals. In this case, they use T equals. And that's usually the way that it will be set up, where it's your dependent variable is equal to your independent variable with whatever is going on in the problem. And then letter B says, a recipe calls for an oven temperature to be 350. Describe the domain and range of the function. Okay, so it's telling us that the recipe calls for the temperature of the oven to be 350 degrees. And it wants us to find the domain and range of the function so we can graph it. In order to do that, let's see how long it takes for, oops, I used Y and X. Let's see how long it takes for an oven to preheat to, so I used X and Y. Let's figure out how long it takes for an oven to get to 350 degrees. Well, 350 degrees represents a temperature. So if I was going to take 350 and replace it in for a variable, will I replace it in for T or M? What does 350 represent? A temperature or a minute? Yes. So I'll take 350 and I'm going to replace it in here for T. And I'm going to solve this equation and see how many minutes it takes to get the oven to be 350. So we've already done this type of problem in previous chapters. So to solve a two-step equation, I first would subtract both sides by 65. 350 minus 65 gives me 285. And then to get rid of the 19 times M, I do the opposite. I would divide by 19. And this answer is going to tell me how many minutes it takes to preheat an oven to 350. How many minutes is that? What's 285 divided by 19? Anyone? Once? Twice? 15. Okay, so that's a long time actually. It takes 15 minutes for the oven to preheat to 350. So it's telling us, it's asking us to create a domain and range of the function so we can graph it. So if we're looking at a table and we have two different variables, we have M for minutes and T for temperature. I know the maximum amount that we need for my domain is 15. Because 15 is the amount of time you need for the temperature to be 350. What's the smallest time that makes sense for this problem, probably? What do you think the starting point is for like an oven when it's just sitting there not being used? Zero, yes. And since we have to go from 0 to 15, maybe we can just go by fives. 0, 5, and then 10, 15. That should be enough. Now what we're going to be doing is taking these other three and replacing them in for M to see how hot the oven will be at that time. So I'll be taking 19 times 0 plus 65 and getting that answer. 19 times 5 plus 65 and getting that answer. 19 times 10 plus 65 and getting that answer. I'm going to try and squeeze it in here. Well, 19 times 0 is 0. And 0 plus 65 is 65. So this one right here will just be 65. Maybe it'll make sense for me to just erase. This one's going to be 65. Bless you. Then I'm doing 19 times 5, and then plus 65. And after 5 minutes, it looks like the oven will be at 160 degrees. Okay, and then this last one, 19 times 10 plus 65, the oven will be at 255. And I'm only erasing because I ran out of room there. So here are 4 temperatures for 4 different numbers we have for the amount of minutes we would be putting on the oven. So now it's asking us to graph. The graph that they gave us isn't going to work for our actual situation here because it goes by 1s or 2s depending on how you look at it, and we need to go up to 15. So these numbers aren't really good. I'm going to change these, and instead I'm going to make them go by 5. So this is going to be 5, 10, 15, and 20. So I'm just going to go over these and go by the numbers that we did. But then for this axis here, which these are labeled wrong, this should be M for minutes, and this should be T for temperature. I need to go all the way up to 350. That is the largest one. So thinking about how that's a pretty big number, you might want to go by maybe 50s. That should work. So going by 50s, 50, 100, 150, 200, 250, 300, and 350. Once you label your X and Y axis, or in this case M and T axis, then you can start plotting the points. So 0, 65 is the first one. It's not going to be perfect. It's going to be in between 50 and 75, 50 and 100, but it'll be closer to 50. So I'm going to put a point there. And then 5, 160 will be a little bit over the 150. 10, 255, and 15, 350 should be exactly on the graph there. So when you do graph it, you should see that these points all line up, and that's because this is called a linear function, which we'll talk about soon. They create a straight line because the oven is heating up at a constant rate of change. And the last thing it wants us to do is determine the actual domain and range of the function. So that means we need to figure out if this is discrete or continuous. And it's hard to think about this. But can you only, what we created was, I just made these numbers up. These numbers in the domain, I said, okay, well, 15 is how long it takes for the oven to preheat to 350. So let's just go by 5 since 15, end it with a 5. 0, 5, 10, 15 makes sense to me in my brain instead of going by 2s or something like that. So I made these numbers up. But are these the only numbers you can leave your oven on to preheat? No, you can leave your oven on to preheat for 9 minutes. You can leave your oven to preheat for if you were upstairs and you forgot about it. Hopefully you don't ever do that, but you can leave your oven on to preheat for 20 minutes. It doesn't necessarily have to be just these numbers. What that means is that these points should actually have a line through them. And the reason why they have to have a line and they're not just discrete points is because you can leave your oven on to preheat for 2 minutes. You can leave your oven to preheat for 9.5 minutes. You can leave your oven to preheat for any amount of time, any fraction or decimal amount of time. It doesn't just have to be an integer. So this domain is actually, or this graph is actually continuous. This is a continuous graph, which is different than the other one, because the other one was about actual sips, taking sips of drinks. This one is different. This one's leaving it on for a certain amount of time. And the domain is not going to just be 0, 5, 10, and 15. The domain for this, I'm just going to put this up here, the domain is going to have to be an interval. And the smallest number in the domain is 0, like you guys told me. And the largest number in the domain is going to be the largest amount of time you would leave it on to preheat. And what's that? What's the longest you would have to leave your oven on to preheat to get it to 350?
15 minutes.
Yeah, 15. So So the domain for this, and unfortunately because they used M and not X, I have to use M here instead. The domain would be this. The domain would be anything from 0 to 15 minutes for your independent variable. And then the range is going to be the minimum that the oven starts at to the maximum that the oven starts at. So then you're looking at these numbers here in the temperature. So what's the minimum? What does an oven, or this particular oven, always start at? Not 0, actually, because then that oven would be freezing. I know this is weird.
What will it be?
Yeah, so like when you don't turn your oven on at all, in this particular one, what does it start at?
65.
Yes. 65 is the smallest number here for the domain and range, which means at 0 minutes, it's at 65 degrees already. That must just be the way that this one is. Which makes sense. Like if you think about room temperature, it's probably pretty close to that. And then what's the maximum in the range? 350. Perfect. All right. Good. Can I see yours real quick? Okay. All right, great job. So we're gonna let me just make sure. We are going to skip a couple things so we can get everything in for today's lesson. So we're going to skip this extra practice. We might come back to it if we need more practice here. But these next two problems are just like those two we did. We're going to skip those. And we're going to go to this page here on page 18 that says Skill 2, Interpreting Functions. So when we're interpreting functions, we're looking at independent and dependent variables, and we're trying to figure out which one's which. We know that the dependent variable is affected by the independent variable. For example, the number of items that you would purchase at a store affects your total cost. So if you're going to the store and you're buying X number of items, the more you buy, the more you spend. Here's an example here that would be like an example of a keystone question like about this type of subject. So a printing company charges for books and adds a delivery fee. The cost C in dollars to have any number of books be delivered to a home is described by the function C equals 10b plus 7. Which statement is true? So they tell us that the cost C, so C represents cost, so this right here represents cost, and they tell us that B represents the number of books. The function says the cost is equal to 10b plus 7. And they tell us that the company charges for the amount of books you buy plus a delivery fee, which makes sense. You usually have to pay for delivery. So, looking at this function, we have to determine which statement is true. Is A true? The cost of 10 books is $7. Not sure. It's kind of random. It says 10 books is $7. I mean, I see a 10 in the function, and I see a 7, but I'm not sure if that's true. So I'm just going to come back to that one. B. The cost of 7 books is $14. I don't know either. It's not like popping out of me as it's right or wrong. So I'm going to move on to the next one and just kind of read it. We're problem solving right now. Each book costs $7 and the delivery fee is $10. That one's kind of intriguing because I see 7, I see 10. And then D says each book costs $10 and the delivery fee is 7. Now, if we look at what I put on this function here, I showed you that the total cost, and I pointed to the C here, is that, and B represents the number of books. Looking at just this right here, what can you tell me about the price per book? If B represents the number of books, what is the price per book then? If the variable B, which represents the number of books, is being multiplied by 10. If I buy 2 books, let's figure out what the price would be. 2 books, I would put 2 in for B. I would multiply 10 times 2, it would be $20. How much does each book cost? $10. And then they add on this $7 just random fee. This is for delivery. So looking at A, B, C, and D, which one is true then?
D.
Yes. Each book costs $10 and the delivery fee is $7. And I can tell that because the number being multiplied by B is 10, which shows me it's $10 per book, plus the $7 delivery fee. Let's look at the next one. A pizza shop charges for pizzas and adds a delivery fee. The cost C in dollars to have a number of pizzas P delivered to a home is described by the function C equals 8P plus 5. Again, let's look at these 4 situations. The cost of 5 pizzas is $8. The cost of 8 pizzas is $13. Each pizza costs $8 and the delivery fee is $5. Each pizza costs $5 and the delivery fee is $8. Which one makes sense for this problem?
C.
C, exactly. So you can see that there is the 8 in front of the number of pizzas here, which means 8 is the cost per pizza, and the 5 is the delivery fee, which makes C the correct answer. Awesome. And then we're going to do this last one together, and then one more thing for today, and that'll be it. A florist charges for roses and adds a delivery fee. These are all very similar. The cost C in dollars to have any number of roses delivered to a home is described by the function C equals 4R plus 7. I can see that a lot of these are very similar in the answers too, so I'm just going to look at this here. How much does it cost per rose? How much does it cost per rose? $4. So I know it's $4 per rose because 4 is being multiplied by R. And then what's this 7? I feel like it was 7 in every problem. What does the 7 represent?
Delivery.
Yeah, this is the delivery fee, which will help me to determine that this has to be C. Oh, wait, no.
I said A.
The cost of 4 roses is $7.
Oh, wait, no.
Okay, it's not A because 4 times 4 would be 16 then plus 7. It's not A. This is about books. Wait, there might not be a right answer.
Yeah.
It says each rose costs $7. Delivery fees. It looks like they forgot to change this word from book to roses. It should be D, but they forgot to change that from the last question. Okay, and then the very last thing for today is skipping this page. So skip over page 19 for now. Skip 20, skip 21. Please go to page, it says 112. It's after page, after these pages with the constructed response. So after page 21, then it says 3-2 linear functions. And then that's a 111. I want you to go to this page here. This page says page 112. So real quick, the last thing for today is looking at linear functions. And the reason why we're skipping around is just because we just did a lot of linear functions. I want to make sure that I go over the vocabulary word for that. So a linear function is a linear equation with 2 variables, usually x and y. So we saw from those problems today that not all of them had x and y. A lot of them had like different variables like c and r. The graph of a linear equation is a line. So when we were graphing those equations from earlier about the preheating the oven, you saw that the points were in a straight line. The amount of juice that was left when you're taking x gulps was a straight line. They can either be increasing or decreasing, but they create a line. A linear function is a graph that is it's not going to be a vertical line. It's going to be increasing or decreasing, and it has 2 variables. A nonlinear function does not have a straight line. So looking at these examples here, just really quickly determining if graphs are linear or nonlinear. Linear functions or linear graphs are straight lines. Nonlinear are not lines. Is A a linear function?
No.
No. This would be considered nonlinear because it's not a straight line. Is B a linear function?
Yeah.
Yes, because it is a straight line. It's that easy. Linear functions are straight lines. You can determine this from graphs, you can determine this from tables, and you can determine this from equations. Looking at tables, you can actually determine if these are linear or not by looking at their increase or decrease. So just last 2 things for today, and then we'll be done. Looking at a table's graph will help me determine what's going on here. If we're looking at the x, from 3 to 6, we would add 3 to get from 3 to 6. To To get from 6 to 9, you would add 3. To get from 9 to 12, you would add 3. So these are adding 3 each time. Whereas these, from 36 to 30, you subtract 6. From 30 to 24, you subtract 6. From 24 to 18, you subtract 6. Because you are increasing and decreasing by the same numbers for the different tables, this would be linear for that first one. This would be linear. But if you look at the second one here, this one is not going to be the case. If I look at the x numbers, I increase by 2, I increase by 2, I increase by 2 to get from 1 to 3, 3 to 5, and 5 to 7. But if you look at the y value, this increases by 7, this increases by 11, this increases by 15. Because these numbers are not the same, like all the other ones were, this is non-linear.